Alright, welcome to today's example from your assignment. You're going to do some more proofs, so you're still using that note paper about the geometric proofs, what you need to complete your proofs, but these ones focus on quadrilaterals, which are four-sided shapes, and there's some special ones, and you're going to be proving whether a quadrilateral is one of these special ones, right? We got parallelogram, we got rectangles, rhombus, and square. Most people are familiar with rectangle and square and even parallelogram, though some people forget about what a rhombus is. Sometimes people call a rhombus as a diamond, but in math terms it's a rhombus. Well, to prove something is a parallelogram, you have to get all the side lengths and all the slopes. And then you have to prove that opposite sides are congruent and they have the same slopes, meaning they're parallel. If you're going to prove a shape is a rectangle, you have to do that same thing, like all this stuff, but also prove that it has right angles, which means the sides are perpendicular to each other. To prove a shape is a rhombus, again, you're going to prove these things, but you also have to prove that all four sides are congruent. If you're going to prove a shape is a square, you have to do both of these things in addition to proving it's a parallelogram. So there's a lot to prove when it's a square, but for any of these, you have to get the slope of all four sides, and you have to get the distance for all four sides. So if you're a bit shaky on getting distance and getting slope, you definitely need to brush up on that and be good at that. It'll make this assignment really easy, because you're going to get slope and distance for all four sides on every problem. So our example today is going to be number 2. And that's because it's kind of got a little bit trickier things on it. But go ahead and you'll be going through this list and getting the distance between all the points and the slopes between all the points. Let's start with KA, and we'll pause it, and then you can get through the rest of these and check it, and we'll continue on from there. So let's look at the distance, or the distance from K to A. Well, that's going to require you to turn this into a right triangle. So you want to count how much it's going up, how much it's going over, which it looks like it's going over 4. Let's see, yeah, just counting there, and we got 1, 2, 3, 4, 5, 6, 6 going up 6, and right 4. And so we can actually do the slope part right now. It's going to be 6 over 4, and you should always reduce your slopes because that makes it so you can compare them easier. So we're looking at 3 halves here. So now you have those, you can set up your figure out your distance here. Distance from K to A is going to equal the square root of 6 squared plus 4 squared. 6 squared is 36, 4 squared is 16, and 36 plus 16 comes out to be 52. So it's the square root of 52. And so you're going to go through the rest of these sides, from A to B, get the slope and distance, E to B, get the slope and distance, and get the distance from K to E. So do that for the other 3 sides. Go ahead and just pause the video and do that, and then come back. Alright, so I got the distance from A to B and the slope for segment AB. The distance is the square root of 116, and the slope is 2/5. If you didn't get those, go ahead and double check. Make sure you're counting that one up 4 and right 10. Make sure you know how to square 4 and square 10, add them together, and make sure you know how to reduce your fractions. So yeah, I'm going to pause and get the other 2 parts. Alright, if you get your other 2 slopes, you're looking at slope for EB over here is 6 over 4, which is 3 halves, and then the distance is again going to be the square root of 52. And then the slope for KE here, it goes up 4 and right 10, so slope is 2/5 if you reduce it, and its length is the square root of 116. So now we have all our evidence. You can start looking at them and see how they compare. So we got distance of root 52, root 116, root 52, and root 116. That means we have 2 pairs of sides that have the same length. And if you look at your slopes, 3 halves, 2/5, 3 halves, and 2/5, you'll see 2 of them are the same, and the other 2 are the same as each other. And so that means that this is looking like it's a parallelogram. If you remember our little chart here, the opposite sides are congruent, and opposite sides are parallel, meaning they have the same slopes. And so we're going to write out the proof now. It's going to look like a lot of gibberish if you're unfamiliar with the notation for things, so highly recommend you know what the notation is from our last lesson. But let's go ahead and write this out. And so we can say that since, let's not do this right. We can write out that segment KA is congruent to segment EB, and we can write that KE is congruent to AB, and that's because they have the same side lengths. I'm going to write that out mathematically. The distance from K to A is equal to the distance from E to B, which equals the square root of 52, and the distance from A to B equals the distance from K to E, which equals the square root of 116. We did that work up there. We can also say that segment KA is parallel to segment EB, and segment KE is parallel to segment AB because they have equal slopes. And I'm just going to add in parentheses that the slopes are 2/5 and 3/2. Look at me, I'm citing my evidence, all this work I did up here. I'm writing it down, writing down the evidence down here. And so that we have that, you can say that thus KABE is a parallelogram. Okay. So these proofs, they have some writing at the end that you need to be able to do. You need to know what these things mean. KA is congruent to EB, KE is congruent to AB, because, and this does not mean segment, it means distance. The distances for those are the same, the distances for those are the same. You can also say the sides are parallel because they have the equal slopes. You have to say what the slopes are, and then you can say it's a parallelogram. So there's a lot of writing on it. That's why this assignment only has 4. But if you got this one done, you're 25% done. Most of the work is just getting all the slopes and distances, which at this point you should be really good at. And don't forget about all these things here of what makes a shape a parallelogram or rectangle or rhombus or square. And if you get stuck, you can look at the solutions for a guide on how to do some of the other ones. Good luck.